Hey there, and welcome back to the deep dive. Today, we are plunging into the pretty fascinating world of Ruby type analysis.
Yes, specifically focusing on a tool called TypeProf.
Exactly.
It's a complex area, definitely,
Yeah.
but really useful, potentially opening up new ways to understand dynamic Ruby code.
And we've got a great source for this, a talk by Yusuke Endoh, Mei. He's a full-time Ruby committer, works at stores.
Right. He gave a really insightful talk at RubyKaigi, super well respected in the community.
For sure. So our mission today is, well, to really unpack TypeProf. Like, what is it? How does it actually work?
And critically, what can you do with it? The practical uses.
Yeah, and we'll even get into some of the really tricky technical challenges they're facing, pulling it all straight from Endo's presentation.
Sounds good.
But before we really zero in on TypeProf itself, Endo's talk actually mentioned a couple of other interesting projects he's involved with.
Oh, right, yeah, the book first, I think.
Yeah, his recent book totally caught my eye.
Ah, yes, the mechanism of the type system. Sounds a bit heavy, maybe.
Maybe, but the goal seems really practical. It actually teaches you how to build your own type checker from scratch.
Which, yeah, sounds like a pretty big undertaking.
Definitely. But he framed it as taking the core ideas from TAPL types in programming languages, that big textbook, and making it accessible.
By showing you how to actually implement the concepts.
Right, exactly, hands-on.
And interestingly, the implementation language he picked wasn't Ruby.
No, it was TypeScript. He built a type checker for, like, a subset of TypeScript in TypeScript.
Huh? Why TypeScript?
Well, he mentioned marketability partly, but also said it was good for explaining certain concepts like tuple types, made it easier to illustrate.
Okay, kind of meta. Using TypeScript to teach type concepts for TypeScript. But I guess it works.
But the reason he brought it up at RubyKaigi specifically was more about encouraging the Ruby community, right?
Yeah, absolutely. To get more people involved in Ruby type development overall, it's about growing that ecosystem.
Makes sense.
And he pointed out the algorithm in the book is actually pretty similar to what tools like Steep and Solve use in Ruby.
Oh, interesting. So there's a direct connection.
Yeah, and to reinforce that, he actually had Sudaro, who developed Steep, and KSSS, a key RBS contributor, review the book.
Wow. Okay. So it's definitely grounded in the Ruby type world, even if the code examples are TypeScript.
Right. Apparently it sold out super fast at the conference.
Yeah. Flew off the shelves, he said. But you can get it online, Amazon, and places.
Good to know. And the other project, the fun one.
Ah, the IRB treasure hunt.
That sounded cool.
Yeah. It's basically a game you play in a browser IRB running on RubyWasm.
Okay.
He said he did the prototype and the story idea, but the main implementation was by Mr. Hogalog, the VPOE at stores.
With input from Mr. Iwaizumi, too, the keynote speaker.
Right. It's a neat way to show off RubyWasm, running interactive Ruby right there in your browser.
Clever. And there's a prize if you find the treasure. He did say it's best on a PC browser, though.
Good tip. All right, so fascinating side trips, but let's get to the main event, TypeProf.
Let's do it.
So what exactly is TypeProf, fundamentally?
Okay, so it's presented as a Ruby support feature, very much under active development. Its main job is doing type-specific analysis of Ruby code.
Okay, figuring out types, variables, methods, returns, all that.
Exactly. But he emphasized it uses a, quote, complicated and unique way compared to maybe more standard type analysis algorithms.
What's the difference? What makes it unique?
Well, this is key for Ruby, right? It's dynamic. TypeProf is designed to do its analysis and make predictions without needing you to write out full, explicit type definitions for absolutely everything.
Ah, okay. Unlike some tools that really lean heavily on having formal specs like RBS files up front.
Precisely. Tools like Steep or Solve can be somewhat limited without that formalization. TypeProf uses its own complex approach to infer types, even in code that isn't fully decorated with signatures.
That sounds incredibly useful for, existing Ruby code bases where you might not have RBS everywhere, or maybe you're just starting a project.
Exactly. It tries to understand your code's intent.
So what does that look like for the developer, like in their editor?
The goal is for it to be pretty seamless. It integrates with editors. He showed it in VS Code with an extension.
Right.
And it gives you feedback, ideally in real time, showing potential type errors, offering code navigation features based on types, like jumping to definitions or finding references.
Okay. He showed a demo, right? What were some of the highlights there? What did it actually do?
Yeah, the demo was in VS Code. One of the first things, and maybe most useful day-to-day, was the automatic type inference.
Ah, yeah.
You could literally see inferred type signatures popping up above method definitions. Like, He had a parser method, and it inferred a
Yeah.
string nil, program node nil.
Just seeing that without writing it yourself is huge. It's like instant documentation.
Totally. Or validation. And it's pretty smart about control flow. Like, if you have a variable that could be, say, string or
Mm.
nil, if you then have an if check, like if my var TypeProf understands that inside that if block, the variable must be a string, not nil.
Okay, that contextual awareness is really important. That's genuinely useful.
Definitely. And then there's navigation.
Right, jumping around the code.
Yeah, standard stuff like go to references to see where a method's called, but powered by the type analysis. And go to definition works as you'd expect.
Does it link up with RBS files if you have them?
Yes, crucially, he showed it can jump straight to RBS declarations too. So it bridges the inferred world and the explicit formalized world.
That integration makes a lot of sense.
And of course, error detection. It showed finding calls to methods that just don't exist on an object, like calling dot plus on something that doesn't have it.
Standard type error stuff. Argument mismatches too.
Yep. Based on inferred or declared types. He also tried to show automatic renaming.
Ah, the demo hiccup.
Yeah, the classic live demo issue.
Yeah.
Had a quick snag, needed an editor restart, but it showed the feature exists or is being worked on.
Still, it shows it's real software under development. What did he say about progress? How far along is it?
Progress seems steady. The code base is around 9,000 lines now. Syntax support is much better, covers more Ruby features, including pattern matching,
That's good.
and a really big milestone. He said TypeProf can now interpret the entire Ruby standard library without crashing.
Wow, okay, analyzing the whole stutlib. That's a serious stress test.
Huge step for stability, yeah.
Yeah.
And he mentioned there's a typeprof.wasm version running in the browser via RubyWasm, though the demo of that part was an older version.
Okay, this sounds genuinely promising. So if someone listening wants to try this on their own project, what do they actually need to do?
The steps seem pretty straightforward to get started. First, you need the editor part. Install the Ruby TypeProf plugin or extension for your editor. He mentioned it works on Cursor, VS Code, those kinds.
Okay, install the extension. What next? How do you turn it on for a specific project?
Right, this is the key bit. You need to create a file specifically named typeprof.com.json or JSON.
And where does that file go?
Right at the root of your project directory, top level.
Okay. And what needs to be in it? Is it complicated?
Nope, surprisingly simple to just switch it on. Minimally, just this JSON TypeProf version.
Yeah.
Experimental.
That's it. Just that line.
That's it, to get it enabled. The idea is TypeProf won't touch a project unless it finds that file.
Ah, that's clever. So installing the extension doesn't mean it suddenly starts analyzing everything on your machine. It's opt-in per project.
Exactly. Keeps things clean.
Yeah.
After you add the file, you probably need to restart your editor, VS Code, or whatever, just to make sure it picks it up.
Got it. And he was pretty upfront that it's still experimental, right? Might not work perfectly everywhere yet.
Oh, yeah. Very open about that. He actually framed it positively, like, if you try it and it breaks or does something weird, please report it. That feedback is gold for the developers.
Makes sense. Bug reports are crucial for improvement.
And he mentioned older talks have more setup details if you hit snags.
Okay. He also talked about a couple of newer, maybe more advanced configuration options in that JSON file.
Right, yeah. Two main ones he highlighted were diagnostic severity and analysis unit bias.
Okay, let's take diagnostic severity first. What's the problem it's trying to solve?
This tackles a common pain point with static analysis, especially early versions: false positives.
The tool flagging things as errors when they're actually fine.
Exactly. TypeProf, being complex and still evolving, can sometimes be a bit noisy, flagging things that aren't really problems in your actual running code. It's a hard thing to get perfect.
Super annoying when that happens. So how does the setting help?
It gives you control over how TypeProf reports things. You can set the severity level, error, warning, info, hint, or even just ignore certain diagnostics completely.
Okay, so if it's showing too many red squiggles for things you know are okay, you can dial it back.
Precisely. Change error, maybe down to warning, so it's less visually disruptive, maybe just a yellow underline instead of red.
So it's about managing the noise level to keep the tool usable, even if the analysis isn't flawless yet.
Exactly. You can still get value from the navigation features, the inference hints, even if you need to tune down the strictness of the error reporting for a while. He mentioned Steep has similar options for hiding certain errors.
Yeah, that sounds like a really practical, pragmatic feature for an evolving tool. He said even just changing error to warning made a big difference for him.
Yeah, made it feel much more usable day to day, less overwhelming.
Okay, that makes sense. What about the other one? Analysis unit bias. What's that for?
This one's all about scale. Big projects, like 100,000 lines of code or more.
Ah, performance issues.
Yep. Analyzing a huge code base as one single monolithic chunk just gets incredibly slow. The internal analysis graph becomes massive and unwieldy.
A classic problem for analysis tools. So how does this setting help?
The idea is to break the analysis down into smaller units, usually based on directories. The analysis can then sort of make assumptions or use summaries about the connections between these units rather than analyzing everything all at once.
Okay, divide and conquer. But how does it know the connections between the units if it's not looking inside?
That's where RBS comes back in. You use RBS signatures to define the public interface for each unit, the method arguments, return types, constants it exports, etc.
I see. So TypeProf can analyze code using a unit just by looking at its RBS interface without digging into all the internal code of that unit every time.
Exactly. So if you have a big component, maybe like a Rails engine or a gem, or if you use packwork, you provide RBS for its boundaries. Then TypeProf can analyze the code, calling it much faster, relying on those signatures.
That can make a huge difference on large projects.
Yeah, he said it helps keep analysis speeds realistic for units that might be, 90K or 100K lines. He explicitly mentioned gems or packwork units as good candidates for this kind of boundary definition with RBS. But he also stressed scalability optimization is definitely still ongoing work.
All right, let's shift gears a bit. One of the most fascinating parts of the talk for me was the deep dive into that really gnarly bug, the one involving Ruby's constant lookup.
Oh yeah, that was eye-opening. It really shows how much complexity can be hiding just under the surface in Ruby. He made it really clear that just finding a constant is surprisingly intricate.
How intricate. I mean, I generally think of it just looking up through modules or classes.
It's way more layered than that. He broke down the order. First, it checks the current class or module context, then any included modules. Then if it's a class, it goes up the superclass chain.
Okay, current includes super. Seems logical so far.
Right. But then, and this is where it gets tricky, it starts looking in the lexically enclosing scopes, like the module or class that contains the current one.
Ah, okay. Outer scopes.
Yep, and only after checking those enclosing scopes does it finally look at the top level, like string.
Wow. Current includes super, then enclosing, then top. That's more steps than I thought.
It is, and there's a critical detail he highlighted. When it's looking in those enclosing scopes, it does not look in the superclasses of those enclosing scopes.
Huh. Why so complex?
He mentioned some of it stems from historical performance optimizations deep inside the Ruby interpreter, implementation details bubbling up to affect behavior.
Wild. So how does this complexity mess with a type analyzer like TypeProf?
It creates a huge headache for keeping the analysis consistent. Imagine TypeProf is analyzing file A and sees string.new. Based on what it knows so far, it assumes, reasonably, that this means the top-level string.
Makes sense.
But then later, maybe analyzing file Z, it discovers you've defined myCoolApp.string. And because of Ruby's specific lookup rules in the context of file A, it turns out that string.new should actually resolve to myCoolApp string, not string.
Oh, so finding something new later can invalidate the earlier analysis.
Exactly. TypeProf realizes its initial assumption was wrong. It has to go back and reanalyze file A because the meaning of that code fundamentally changed based on discovering myCoolApps.string.
Okay, I can see how that gets complicated fast.
And include makes it even worse. An include some module can totally change how constants resolve within a class. If TypeProf sees an include that shifts the lookup path, it might need to reanalyze everything in that scope that used any constant because they might all resolve differently now. He emphasized TypeProf is built to trigger this reanalysis aggressively, which is necessary but also dangerous.
Which leads us to the infinite loop bug.
The infamous one, yeah, reported by Alpaca Taichu. The code that triggered it was incredibly minimal but devious. Module M end, include M, end.
Wait, say that again? An outer M, an inner M inside that, and then inside the inner one, you include M.
Yep, sounds like a brain teaser, right? And a perfectly trapped TypeProf reanalysis logic.
Okay, walk me through it slowly. How does that loop?
So first pass, TypeProf is inside the inner M. Let's call myAppEm. It sees include M. Follow Ruby's rules in that context, M resolves to the outer M.
Okay.
Seeing this include M statement changes the scope of myAppEm. So TypeProf says, okay, scope changed, must reanalyze myAppEm.
Right, trigger reanalysis.
Now, during the reanalysis of myAppEm, it hits include M again. But this time, because it's reanalyzing, the inner myAppEm itself is now visible earlier in the lookup path within that scope. So include M resolves to the inner myAppM.
Hold on. First time, include M resolves to outer M. Second time, during reanalysis, include M resolves to inner myAppM.
Exactly, and that's the trap, because resolving include M to the inner myAppM also changes the definition of the scope, so it triggers another reanalysis of myAppM.
Oh, no.
And now, on this third pass or second reanalysis, when it hits include M, where did it resolve last time, the inner myAppM, is there another M inside myAppM? No. So following the rules again, it fills back up the chain and resolves include M back to the outer M.
Which triggers reanalysis, which
Yeah.
resolves it to the inner M, which triggers reanalysis, which resolves it to the outer M. What?
Infinite loop, purely from the interaction of Ruby's complex lookup rules and the necessary reanalysis logic of the tool.
That is just remarkably subtle. It's not really a bug in the user's code per se, it's the code exposing a fundamental difficulty in the analyzer dealing with Ruby's rules.
Precisely. It shows how deep you have to go. And he mentioned rbs.inline actually had related issues, not an infinite loop, but it could get constant resolution wrong in similar tricky cases, leading to type checks passing, but runtime errors.
So how did they fix this infinite loop? Did they find a way to make the analysis perfect?
Well, after a lot of back and forth, including talking with the rbs.inline author, they reached a pragmatic conclusion. Trying to perfectly track constant resolution in every single possible permutation of nested modules, includes, and dynamic changes is basically intractable for a tool like this without becoming impossibly slow or complex.
They had to draw a line, accept some limitations.
Pretty much. They decided that in these extreme edge cases, driven by Ruby's most complex lookup scenarios, TypeProf might just have to accept it can't perfectly model every dependency or catch every related type error.
So what was the specific fix for the loop?
For that specific module M, include M, end, structure, they adjusted TypeProf to just consistently resolve include M to the inner myAppM. That breaks the loop.
Okay, so it stops looping, but it might mean the analysis in that very specific weird case isn't technically 100% accurate according to the most rigorous interpretation of Ruby rules.
Exactly. It's a trade-off. Stability and progress over theoretical perfection in the absolute deepest, darkest corners of constant lookup. It keeps the tool moving forward. And he warned RBS inline users might face similar situations.
It really sounds like building these kinds of tools for a language as dynamic and, well, flexible as Ruby means, constantly wrestling with these deep challenges baked right into the language itself.
Absolutely. It's a dance between what Ruby allows and what a static analysis tool can realistically model and keep track of. TypeProf is definitely making progress towards being practical, but yeah, problems like this show just how hard it is.
So wrapping up, the message for listeners seems pretty clear.
Yeah, give TypeProf a try. He was really encouraging. Install the extension, create that simple config file, see what it does on your project.
And if it doesn't work, or seems off,
Report it. Bug reports, examples of where it gets confused. That's super valuable feedback right now. And hey, if you're feeling adventurous, maybe even contribute.
and if that whole constant lookup deep dive got you curious about how type checkers work internally.
Check out Endoh's book, available online. It's a great way to understand the foundations.
Well, that was quite a journey, wasn't it? From the practical features and setup of TypeProf through improvements for noise and scale.
And right down into the weeds of Ruby's constant lookup. That infinite loop example was something else.
It really highlights that building powerful tools for dynamic languages involves more than just algorithms. It's about deeply understanding and sometimes having to work around the language's own quirks and complexities.
Makes you appreciate the effort involved in just getting those red squiggles under potential type errors to show up reliably in your editor.
Totally. It's a massive undertaking.
Testament to the folks working on it.
So, as we finish up, maybe a final thought for you, the listener. What does this glimpse into the intricate machinery of something like constant lookup tell us about the hidden depths in the languages we use every day? And how does grappling with those complexities shape the tools we build to understand our own code?
Definitely something to chew on.
Absolutely. Thanks for joining us on this deep dive. We'll catch you on the next one.